now. We can either go on to homework 4. So on Wednesday, before we take the test on Friday, we'll definitely take a practice test. Do you want to go ahead and take one practice test right now? And then we'll cover homework 4 like on Friday and Monday, and then take another one on Wednesday. Does that sound like a good plan? JP likes that plan. How's everybody else feel? Everybody else feels good? Okay. So let's go to homework and tests. So practice exam 1. I'm ready to start. Yeah, you can do them as many as you want to. And if you feel uncomfortable and you want to come to office hours and take one with me sitting right beside you, that's okay too. So, all right. Given data represent number of people age 16 or, wow, I can't read, 25 to 64 who's subscribed to a magazine. Frequency polygon, applying loose interpretations of the requirements for normal distribution. Does it appear to be normally distributed? So, what do you think? Is there anything we can rule out before we even get started? B. Why B? Yeah, they have to start and stop at 0. Any other ones? Yeah, A looks kind of funny too. What looks funny about A? Yeah, I don't know what else to say about that. But it's like on all of these like frequency distribution things, we kind of tend to go out a little bit before the first one and a little after the last one. So yeah, it's either got to be C or D. And out of C or D, which one looks right? Okay, I heard 2 people. Well, should we get y'all to fight? I don't know. Somebody said C. Why did you say C? Okay, I don't know who said that one. Somebody who said D. Why did you say D? Yeah, I mean, the first dot and last dot, that's just the zeros on the end. I mean, the 4 in the chart should be the 4 guys in the middle, right? The big number in the chart is the second one. So, yeah, there's a big spike at the second one. The third one's a little lower. The first and last are roughly the same, so that looks like D. Oh, no. There's more to this question. So does this appear to be roughly normal? Very, very roughly normal. Yeah, I mean, it's not really symmetric, but I think it's close enough. So, yeah, it goes up to maximum, it decreases, and it's very, very roughly symmetric. So, okay. 16 questions. Nominal ordinal interval ratio is most appropriate below. Social Security numbers. So let's, I mean, everything's nominal. I mean, if you have a Social Security number, it tells you what your name is or whatever, what group you're in. Does the order of Social Security numbers mean anything? No. I mean, so, and that's, once you get there, it's like, okay, I mean, it's in order. So if you're not ordinal, you're definitely not interval, you're definitely not ratio. So once we cross one out, we know we're not any further up the list. So that was easy. Probability of a boy is 0.523 among the next 4 randomly selected births. What's the probability of at least one girl? So again, all these at least ones, the easiest thing to do is find the probability of no girls and then do 1 minus that. That'll give you the probability of at least one girl. So what's the probability of no girls? How would I find it? Yeah, no girls is the same as all boys, right? So Probability of the first one being a boy is 0.523 times probability the second one is a boy, another 0.523, and so on. So 0.523 all 4 times. So that's the probability of all boys. So the probability of at least one girl is 1 minus that. 0.925. So, is everybody happy with that one? Okay, well, Excel decided to crash on me. So I guess we'll go on. Yep, we are still recording. Game show must select a door. If one door doubles the money, the other doors leave her bankrupt. What's the probability she selects the door that doubles her money? Yeah, there's one out of 4. Does it have potential to create bias? So a medical organization opposes the use of meat and dairy products in our diets, and that organization has received hundreds of thousands of dollars from an animal rights foundation. Does that appear to have a bias? Yes, it does. Yeah, there's an incentive. Or, yeah, I think A's. Okay. Yeah. Okay. Histogram. What is the class width? So class width is what? It's from where one starts to where the next one starts. So 110 to 120 is 10. So the upper and lower limits of the first class. So 110 to 120. And that looks like it. Okay. The Richter scale is below. Find the mean and median. What's the magnitude? It's an outlier. Consider to explain. Okay. So, and now we're really happy to have a computer because even though finding mean is really easy, it's just add up and divide by how many. Do you really want to add up all those numbers and divide by how many? How many numbers are there? You want to add up 50 numbers and trust yourself to type the right thing every time? All right. So if I want Excel to do this for me, what's the command for mean? Average. And okay. I missed the days of the mouse. There we go. And down to 850. All right. There's my average. And while I'm at it, how do I do the median? Median. And the same thing. A1 to A50. All right. Three decimals will just be 128. Oh, where'd it go? Yeah. And median. So would you think a 7.0 would be an outlier? Yeah, that's very far away from everything else. Okay. We just did that problem. Let's do it again. All right. So we're going to do a problem very much like what we just did. So the probability of heads on the biased coin is 0.75. So let me write, come on. Okay. So the probability of two heads given the, let's say B for biased, is, how would I find that? Annie, come on, you know it. So 75 on the first flip, 75 on the second flip. So yeah, 75 squared. And then again, the probability of two heads given not biased is 0.75, or not 0.75, 0.50 squared, right? So the probability of biased given two heads, well, it's the probability of two heads given biased times the probability of biased over probability, same thing again. And then the probability of two heads given not biased and probability of not biased. Oh, sorry. Turn the phone off. All right. So 0.75 squared. And there were three coins, right? Yeah, three coins. So the probability of biased is 1/3. 0.75 squared, 1/3. 0.50 squared, 2/3. Right. Okay. So 0.75 squared divided by 3 is that, divided by parentheses 0.875 plus 0.5 squared times 2 divided by 3 is 0.529. Less than 4. Okay, we're doing cumulative frequency. Less than 40. How many? 3. Less than 45. 7. Less than 50. 12. Less than 55. Less than 60. 32. Scroll down. Less than 65. 31. And less than 70. That's all there was to that problem, isn't it? Okay. Coefficient of variation. What's coefficient of variation? Yeah, standard deviation divided by the mean. So, which in Excel is average. So. What are we doing? All right. Okay, so as Catherine said, we want to do the standard deviation. What's standard deviation? D dot S. Divided by the average. by average of that same list. All right, so that's for candidate A. If I want to get candidate B, I could do the same thing, or what else could I do? Yeah, just grab the little box in the corner, pull it over, and it knows to do the same thing in the other column. So for A, it's 36.1, and for B, and for B, no, that's 36.2 and 45.1. So is that a pretty good difference? Yeah, it says anything bigger than 1% is pretty good. So A has significantly less than B. Where he states 35 or add, the sum is divided by 35. The result is that. Is that a statistic or a parameter? What's the difference between statistic and parameter? Okay, while we're at, what's the difference between population and sample? Right. So there's 40 states we actually care about. There's 35 that we study. So 35 is a sample. A parameter is a number describing the population. A statistic is a number describing a sample, right? So this would be a statistic. Some meaningful way in which the ISQ scores are matched with the brain volumes. If they are matched, does it make sense to use it in the same column? Why not? Let's look in Excel. Even though there's only 5, we could probably just eyeball it, but let's use Excel anyway. And again, Excel is warning us of something. Okay, so if you want to see if there's a correspondence, easiest thing to do is just make a graph of it. That little recording thing is right in the way. Let's do this somewhere else. Okay. And, insert a scatter plot. Okay, that did not do what it was supposed to do. Try it again. Insert. I'm really thinking we should just eyeballed it. It would have been easier. There we go. Get smaller. Don't move. Get smaller. There we go. Does that look like there's any sort of real relationship between the X's and the Y's? No. So, yeah, even if it was, the sample size is pretty small anyway. If they are matched, does it make sense? No, they're not matched anyway. Oh, I'm sorry, they are matched. Okay, sorry. I was misreading this. So they are matched because it says, okay, here's the brain volume, here's the person, here's the brain volume, so they're matched. Do they have anything to do with each other? No. Okay. Anyway, okay. We beat that one with the dead horse. See if we can finish. We got 4 more questions. Illustration 9 on people, and that finds 31 of them respond. Okay, that. Okay, probability of getting someone in the 18 to 21 age bracket or someone who responded. So I want everybody in the 18 to 21, so all 99 of them. And I want everybody else who responded, right? Which is 241. Right? So I've got the ones that I care about. Well, I've got altogether, I've got the 99 in one group, and the 262 in the other is my totals. So I talked to 361 people. Out of those, well, there was 99 that was in the right age, and then 241 others that responded. So, yeah, that's right. And it does 1 decimal. So the probability that I got one of those two is 340 divided by the 361. 942. Sorry, we're kind of rushing, but that's because we started 20 minutes late. So what's from, okay. Let's see if there's a fast one. Oh, that one's not terrible. Okay, let's do this. A researcher selects every 475th social security number and surveys the corresponding person. What is he using? Systematic. And that one looks kind of long too. So, all right, let's call that good. So we submit the test, and hopefully we only missed the 2 that we didn't do. Yep, we only missed the 2 we didn't do. All right, cool. So I guess the next couple of days we'll go through homework 4, and then we'll practice for the test one more time for the real food.